This is the second session on solving for unknowns, where we'll be looking at solving for ratios and inequalities. The next problem type is solving for a ratio, where you have one equation and two unknowns, so you can't solve the variables for specific numbers, but you can solve for their relative amounts. If you want to try the problem on your own, you can pause the screen now. Since we're dealing with relative amounts, you can also use the substitution strategy. So for this to be true, well, if y were equal to 3, then the numerator would have to be equal to 2. So we have 3x minus 3 has to be equal to 2. Add 3 to both sides. 3x is equal to 5. Divide both sides by 3. X is equal to 5/3. So x over y is equal to 5/3 divided by 3, which is, on your calculator, you would get 0.5 repeating. Or you could also have done it dividing by 3 is the same as multiplying by 1/3, which would have given you 5/9. And this could have been a grid-in or a multiple choice question. Algebraically, when you have fractions on opposite side of an equal sign, cross multiplication is a good strategy. It'll get rid of the denominators. So you'd have 2 times y is equal to 3 times the numerator, which would be 9x minus 3y. And to get a relative relationship, you want to have the variables on opposite sides of the equation. So if you add 3y to both sides, you get 5y is equal to 9x. And our target is to get it to look like x over y. So we want y on the bottom, so we divide through by y. So we have 9x over y is equal to, y's cancel out, 5. And we divide both sides by 9, we get x over y equal to 5/9. So that would be the algebraic solution. The next problem type is inequalities. If you want to try this on your own, you can pause the screen now. With a two-sided inequality like this, you want to take each side separately. So on the left-hand side, we have 2x minus 4 is greater than negative 10. And the rules for manipulating equations also apply to manipulating inequalities, with one exception. So you can add equals to both sides, subtract equals from both sides, multiply equals on both sides, and divide both sides by equals. And it maintains the inequality, again with the one exception which we'll get to later. So if we add 4 to both sides, we get 2x is greater than a negative 6. Divide both sides by 2, x is greater than a negative 3. Okay, well, it looks like this solution. On the test, they'd probably have another one with a negative 3 in it. But let's check the other side now. We have 2x minus 4 is less than 8. So add 4 to both sides. So 2x is less than 12 divided by 2x is less than 6. So B is our answer. And the one exception is if you multiply or divide by a negative number. So, like if you have, say, a negative 2x is less than 10. To get x by itself, you have to divide by a negative 2. So we have a negative 2. So that evaluates to negative 5. But if you multiply or divide by a negative number, it reverses the inequality. For example, let's say 8 is greater than 2. If you add 2 to both sides, it's still true. If you subtract 2 from both sides, it's still true. If you multiply both sides by 2, it's still true. If you divide both sides by 2, it's still true. But if you multiply by a negative 1 on both sides, what happens? We have a negative 8 and a negative 2. And now, which is greater? So that's the one case we have to be careful. If you multiply or divide by a negative number, it reverses the inequality. This is an inequality with an absolute value. If you want to try this on your own, you can pause the screen now. The multiplication by 2 has nothing to do with the absolute value per se, so you could divide both sides by 2 and get x minus 4 is less than 6. Since you can think of subtraction as a distance, you could think of this as all points whose distance from 4 is less than 6. So they would be all points less than 6 in that direction and less than 6 in that direction, or between negative 2 and 10, which is B. And in general, the form would be x minus h, where h is the center point, all points whose distance from that is less than some distance. And if you did it algebraically, you would have two equations. You would have x minus 4 is less than 6, add 4 to both sides, x is less than 10. In high school, you probably taught the second equation as being x minus 4, reversing the inequality and making this negative. But the way I like to think about it is that if you had x minus 4, if it came out negative and you took the absolute value, it would be less than 6. So distributing the negative, you have minus x plus 4 is less than 6. Subtract 4 from both sides, minus x is less than 2. Multiply both sides by a negative 1, so we get x and negative 2. But remember, if you multiply or divide by a negative number, it reverses the inequality. Since the distance has to be represented as a subtraction, if you had something like, say, x plus 4, you'd have to represent this as x minus a minus 4. So this would be saying all points whose distance from minus 4 is less than 6. So 6 this way would be a minus 10, and 6 this way would be a positive 2. A variation on that would be to give you an equation like this and 5 different graphs and ask you which graph represents this relationship. And a key to that is remembering that this absolute value can't be less than 0. So you want to start at where would this be equal to 0? Well, at x is equal to 4. 1, 2, 3, 4. So as you go on either side of 4, then, so for example, as x goes equal to 5, it can only get greater. And as x goes on the other side of 4, the absolute value also has to get greater. So like 3, if x is equal to 3. Okay, that's -1, but then it becomes a +1. When x is equal to 2, this becomes a -2, but the absolute value becomes 2, and so on. So as you go on either side, you're going to get a value like that, a graph like that. And of course, you can always plot a graph point by point, but the key here is understanding that looking for the x value that makes this 0, because that's going to be the vertex point. And if you have, say, something like y is equal to 2 times the absolute value of x minus 4. Well, that just makes it move faster. As x moves, y moves twice as fast. So it would be like this. And then anything that's outside this shifts it up or down. So this would be if it was, say, let's say minus 5. It would just shift this down 5. 1, 2, 3, 4, 5. So it would be like that. If you want to try this on your own, you can pause the screen now. The previous problem gave you an inequality and asked for the range that it represented. Here you're given the range and asked for the inequality that it represented. So tomatoes have to be between 0.8 and 1.6 pounds. Well, the general principle is you're looking for all points whose distance from midpoint is less than a certain distance. So first you have to get the midpoint, which is by adding these, which is 2.4, and dividing by 2, which is 1.2. Okay, and then the distance is 0.4, just to make sure, check on this side. So we're talking about all points whose distance from the midpoint is less than 0.4, which is C. This is the end of the second session on solving for unknowns, and next we'll be looking at converting what's given to what's asked and solving for a parameter. And as usual, these are problems on the Blue Book's practice test where you can practice solving for unknowns.